G'day folks, Mr. Baker here to help with another chemistry question. Now, if we look at the start, we've got the hydrochloric acid in excess. Hydrochloric acid will have a pH between about 0 and 3, so that's where we're going to start our graph. The copper oxide's going to neutralise the hydrochloric acid. That'll leave a neutral solution of pH 7. So here's what our graph should look like. Starting about pH 1, gradually increasing until all of the copper oxide has neutralised the hydrochloric acid and the solution remains at 7. It doesn't go any higher because the copper oxide is insoluble in water. It won't dissolve and release hydroxide ions. Take a careful look at the diagram of the equipment. We're going to need it to answer the next question. This question is very similar to required practical 5, measuring the rate of reaction by collecting a gas. Here though, we're just asked to write about how we could work out the total volume of gas produced from the reaction between magnesium and hydrochloric acid. It's important in questions like this to set out your answer clearly and logically, using the correct names for pieces of equipment as you go. Our answer needs to be accurate, so we've got to make some measurements. First of all, measure out the mass of magnesium using a balance. You might want to say how many decimal points the balance might measure to. 2 would be a good example. Second, we've got to measure the volume of hydrochloric acid using a measuring cylinder. Make sure that excess acid is added so that all the magnesium reacts. We're going to put both of those into a conical flask like in our diagram. We're going to add a bung in there to trap the gas, and then a delivery tube is going to take the gas to a gas syringe, which is going to measure the volume of gas produced. As the volume of gas increases, the magnesium will be being used up. So once all the magnesium is gone, we'll see no more bubbles, the magnesium will have disappeared, and that will be the maximum volume of gas produced. Simply read off the scale on the gas syringe, and to make our answer accurate, we're going to repeat the experiment and calculate a mean from the answers that we get. It's important that for each repeat, we keep the control variables the same mass of magnesium, the same volume of hydrochloric acid, the same temperature, because all those kind of things could affect the total volume produced. Okay, I hope you've got that calculator still with you. We need to calculate the gradient. The equation for gradient is the change in the y-axis divided by the change in the x-axis. Now, because this graph starts at 0, 0, we can just read off how high and how wide each part of the graph got. So, the change in y is 4.8 and the change in x is 6. 4.8 divided by 6 is 0.8. So that's our answer. Now we have to do a bit of thinking for this final part, but we're richly rewarded if we put our brains to it. We know, we've just calculated, that 1 gram of copper oxide will make 0.8 grams of copper. But we've got 75 grams of copper oxide. So if we multiply both of those by 75, it tells us that 75 grams of copper oxide will make 60 grams of copper. There are a few other ways to calculate that, but that's the simplest by far. One thing that's important to note is, for the last 2 calculations, I've shown my working really clearly. That can help an examiner see what you're trying to talk about, even if you're not quite sure yourself.